Hi, I'm Kirill Gavriluk. I work on Azure Cosmos DB, and over the next few minutes, I'll introduce you to the power of the combination of Azure Cosmos DB and Azure Functions. If you're not familiar with Azure Cosmos DB, it's a globally distributed, massively scalable, multimodal database service. It offers global distribution at its core. It allows you to bring your data anywhere in the world, wherever your users are, completely transparently to your application, thanks to turnkey global distribution. It's a multimodal database service, so it allows you to work with documents using SQL or MongoDB API, with key value pairs using Azure Table API, with graphs using Gremlin API, and now we also announced Cassandra API. It's a fully managed service that elastically scales transparently to you. You don't need to think about instances, servers, CPU, memory. You need to tell us how much throughput you need, and we guarantee it with 4.9 SLAs. And transparently for you, we will scale out as the amount of data grows and as your throughput goes up and down. It offers you 5 intuitive choices of consistency, each with a clear trade-off between consistency desired and performance. It is a fast service offering single-digit millisecond latency in the same data center, guaranteed with 4 SLA. And it is the only cloud service that offers you SLAs not only for availability, which is 5 nines, but also for throughput, for consistency, and for latency, 4.9 SLA. Now, Cosmos DB has integration with Azure Functions. Both of them represent serverless offerings. Cosmos DB does not require you to think about servers. It only operates in terms of throughput. Azure Functions do not require you to think about instances and servers. You write your code, and it will make sure that it executes as much in parallel, as much as needed to process the input. Together, Cosmos DB and Azure Functions, thanks to Cosmos DB Trigger for Azure Functions, allow you to build completely serverless, event-driven solutions. Let's take a look at the demo. Here I have an Azure Cosmos DB account with a temperatures collection that contains simulated reading from a bunch of sensors, temperature sensors. As you can see, we have some traffic, not too much, but sufficient for our demo purposes. And here's how the data looks like. Using Data Explorer, we can see that the collection contains entries with temperature readings and latitude and longitude. What I want to do is I want to trigger a function, trigger a code that sends us an SMS message to me in response to a temperature change that exceeds 80 degrees, right? So a little bit of logic in addition to listening on changes. It's very easy to do, to add a function that listens to changes in Cosmos DB database. You can do it right from Cosmos DB account portal. Just click Add Azure Function right here. Select a collection that you want to listen on. Select the function app, which serves as a container for your functions. And then name your function, which is good, and click Save. What it does is it will create a function and will configure it correctly to listen on your Cosmos DB account on the collections that you specified. Let's take a look at the code. The default code is very trivial. Let's replace it with a code that does listen on changes. And in case if the temperature exceeds 80 degrees, sends an SMS message. The last thing we need to do is configure Azure Functions with the SMS Twilio output binding. Let me use, you can do it using UI, but I have the binding configuration right here. And so we'll go into the bindings configuration file and add Twilio SMS output binding. Note that I also have here the Cosmos DB trigger input binding. And one thing that I wanted to point out is Lisa's collection. This is a collection that helps Azure Functions scale transparently for you as the rate of changes increases or decreases in your collection. So you don't need to worry about it. You just write code and it will execute at the rate is required to keep up with changes in your collection. Let's click Save. And then let's go to the back to our collection, and let's add a new document, a new temperature reading entry that exceeds 80 degrees. Note that I could have used, I'm using SQL API here with Azure Cosmos DB. I could have used Mongo API or Graph API or even Table API if I needed to. They all work with Azure Functions integration. We do need to ensure that the ID is unique. And there we go. So now we can go to Google Voice and hopefully receive the SMS message. And it just arrived. Here's the message from our Azure Functions telling us that the temperature exceeded the threshold. In just a couple minutes, I was able to add code using Azure Functions that listens on changes in my Cosmos DB collection and triggers an SMS message, and all with just a couple lines of code. That's very powerful, and it allows you to build completely serverless, event-driven architectures for your solution. Let's go back to the slides to see what our customers are doing with this. What you just saw is in 1 minute, I was able to integrate Cosmos DB with code running in Azure Functions so that that code gets invoked whenever there is a change in Cosmos DB. And note that I can add as many functions as I need to, all executing in parallel and processing specific actions that I need. This allows me to build event-driven architectures using microservices approach. Each function is an independent microservice that I can manage separately, I can write and implement, and they all run in parallel. And thanks to the fact that it's a serverless platform, I don't need to worry about servers, managing those individual microservices. Together, Cosmos DB plus Azure Functions gives you a serverless platform for your event-driven apps. The underlying foundation for this integration is Cosmos DB Change Feed API. Very useful if you need more control over compute than what Azure Functions gives you. With Change Feed API, you can subscribe to individual changes on individual logical partition ranges and integrate with your custom workers, with Spark or HD Insight or Storm, build event-driven architectures, build data movement architectures, anything you really need whenever you need to subscribe to a change in the database. Change Feed comes with a simple library called Change Feed Processor that encapsulates all the aspects of listening and determining which partitions to listen on, and allows you to just write code in a Change Feed Processor, and it transparently for you allows you to scale out easily your processing solution among as many workers as you need. That's what Azure Functions are using. With that, my ask for you is to give it a try. You can try Azure Cosmos DB for free now, no sign-up or credit card required. Using this link, you can get Azure Cosmos DB fully featured account for 7 days without a credit card or Azure subscription. You can do the same with Azure Functions. You can look for more videos on Channel 9, and please continue your education on Virtual Academy online. Thank you for listening.